Okay, in this section we're going to talk about how exponent rules apply to these radical expressions, and we want to always think of these radicals as fractional exponents because we have nice rules for exponents, and the notation is a little less cumbersome when you don't have to have those square root signs as radicals all over the place. So let's talk about just a few rules with radical expressions with exponents. Okay, so our basic radical exponent rules are: if I've got x to the 1 over n, that's the same thing as the nth root of x. That's one of them. We've got x to the m over n. All right, that's m copies of x to the 1 over n. So that's 1 over n. There's that bit, and then x to the mths on the inside. You could also do it this way. You could take the nth root of x, and you could raise it to the mth power. Either of those things are equal. And we've got our other basic rules, right? For exponents, x to the a times x to the b. This is x to the a plus b, and that works if a and b are fractions too. X to the a to the b. This is x to the a times b. Right. If I've got b copies of a copies of x, I've got a times b copies of x. I've got x to the negative a. That's also written as 1 over x to the a. That's a pretty common one. And these are our basic exponent rules. I should probably, well, combine maybe one of these, this one, right, with the division, x to the a over x to the b. This is the same thing as x to the a times x to the negative b, which by the addition rule, this is x to the a minus b. So all our original exponent rules apply. Let's see it apply to some of these fractional exponents, right? So let's say if I have 4x to the 4th to the 1/2, well, this is a multiplication inside. This exponent applies to everything that's inside this parentheses with multiplication, right? So this is 4 to the 1/2 times x to the 4 times 1/2. So this is the square root of 4 is 2, and I've got 4 copies of x, but I only want half of those, so I really only have 2 copies of x. So this is 2x squared. Let's look at, say, can I do this? I've got negative 16, I've got y cubed, and I'm taking the 6th root of that. Okay, so this is an even, the 6th root of that. This is an even root, right? This would be the 6th root of negative 16 y cubed. And I've got a negative sign inside of an even root. This is not a real number. Okay, so we can't actually write down what that number would be. We could use imaginary numbers, but we're not there yet. So we're just going to say it's not a real number. Let's look at maybe, say, x plus 5 to the 8th to the 1 over 8, right? So I'm taking the 8th power of something, and then I'm taking the 8th root of that 8th power. Well, this is even, right? And so the even roots, they always give me something positive out, so I'd like to say it's just x plus 5, but it has to be positive all the time, so I'm going to put it in absolute values so that I get that positive root out all the time. Okay, so there were some basic ones. Let's do a few more where I actually get to apply some exponent rules a little bit. So let's look at, say, m to the 2/3 times m to the 1/3 to the 6th power. Okay, there's a couple different orders that we could do things, right? I could move the 6 and apply it to both of these first, but one thing I really notice right away is I've got 2/3 of an m here and 1/3 of an m here, so these two things together just give me a full m. This is m by itself inside the parentheses by adding these two exponents. 2/3 plus 1/3 is 1. So I've got an m to the first on the inside, and then I get a 6. So m, this is just m to the 6th. Another thing we could do, let's look at, say, x, say y to the negative 2/3. I'm going to take that whole thing to the negative 3/5 power. Okay, so I don't really care for negative exponents so much, so let's see if we can get rid of these negative exponents a little bit and simplify stuff, move it together. So I'm going to deal with the inside of the fraction first. So because I call this a fraction is because it has negative exponents. So I've got an x, and I've got a y to the 2/3 in the denominator because of that negative exponent on the 2/3, right? Negative exponents belong in the denominator, but you make them positive after they go down there. And then I've got this negative 3/5 on the outside still. Okay, that negative says I need to flip the fraction over, right? This is moving the denominator up to the numerator down to the denominator. So if I get rid of that negative, I will have a y to the 2/3 on the top, I will have an x on the bottom, and that still leaves me with this 3/5 here. Okay, and now this 3/5 applies both to the y and to the x, so we're going to bring that inside. We're going to have a y to the 2/3 times 3/5, because my exponent rules say if you have an exponent on an exponent you multiply, and then I have an x to the 3/5. Okay, so all together the y bit, the 3's cancel when I do that multiplication. I have a y to the 2/5 divided by an x to the 3/5. And there's the result of that. Let's see, maybe a couple more examples. Let's look at the 4th root of 25b squared. Okay, so what can we do here? This is the 4th root of 5 times 5, if I factor this out, times b squared. We're going to rewrite this as 5 squared times b squared to the 1/4. So this is 5 to the 2 times 1/4 times b to the 2nd times 1/4. So this is 5 to the 2/4 times b to the 2/4, which is 5 to the 1/2 times b to the 1/2, which is, it's the square root of 5b. Okay, so that 4th root, it turned into a square root because I had 2 copies of everything that was inside of it. Let me see if there's anything else that looks like we should talk about. Oh, let's try this one. Let's see how we distribute across addition. So I've got y to the 1/3, and I've got this parentheses, I've got y to the 2/3 plus y to the 5/3. Okay, there's no exponent outside here, so I don't have to deal with distributing exponent and this addition. And if you have exponents and you have an addition, you have like this foiling thing that you have to do, right? So I don't have to do any of that foiling stuff, which is good. All I have to do is I have to distribute this y to the 1/3 to both pieces here. So we're going to have y to the 1/3 times y to the 2/3 plus y to the 1/3 times y to the 5/3, and I have 1/3 of a y and 2/3 of a y. That means I have a full y here, y to the 1st. I have 1/3 of a y and 5/3 of a y. That means I have 6/3 of a y there, which is 2. So this is y plus y squared. So this simplifies to y plus y squared. Okay, that should get you through all of the problems in 7.2.